Hey, hi everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we are going to solve a very important problem that is called 0 1 matrix. This question has been asked in a top companies like Amazon, Microsoft and Google. And the best part is it helps you to understand a very powerful concept called multi-source BFS. So let's dive into it. Before moving forward to the intuition approach, dry run and solution, let's dive into the problem statement. What problem is saying? Like we have a grid or matrix of n cross m that will contain only 0 and 1. Now our task is to find the nearest 0, find the distance to the nearest 0 for each cell. We can move in all the four direction, upward, downward, left and right, and each move will cost 1. So in a very simple manner we can say that we need to find the near distance for the nearest 0 for each cell. That means for what will be the nearest 0 for this 0 comma 0, that will be 0 because this is already a 0. Now coming to this one, what will be the nearest distance, what will be the distance for the nearest 0, that will be 1. Like we can go upward, downward, left and right, that will be 1. So like you can directly calculate this time you can directly calculate the distance by watching this matrix. Now we need to you know logically solve this question, like for the for thousand cross of the thousand cross thousand matrix. So we need some logic. So coming to the intuition, what will be our intuition for solving this particular problem? At a first glance you might think for everyone find nearest 0 using BFS. That means we need to run BFS for everyone. Yeah, this will be a solution, but you know for running BFS for everyone, that will cost that will a very time taking process. That means we need to call for this, we need to call for this, we need to call for this, we need to call for this. So it would be very slow. Instead of this we can think reverse. We can use reverse engineering. We start BFS from all zeros at once. That means we in a like we have solved the problems of multi BFS, that was rotten oranges, where we store all the rotten oranges in the queue, and after that we start iterating and calling BFS for that particular node. So that's the same. Like we need to store all the 0 inside a queue, and after that we need to check for that remaining 1. So we start BFS from the 0. That's what multi-source BFS is. Coming to the core idea, what will be our core idea for that solving this particular problem? Like we know the template of BFS, that we need to take a queue, we need to post the element inside this queue, we need to mark it as visited, and checking the adjacent of that particular node. So that's the process. So coming to the dry run, let me raise it first. So let me create a queue. This is what queue is, and what we need to do firstly we need to push all the 0. That means we need to iterate over this matrix and check whether that particular node 0 comma 0 0 comma 1, what will be that is 0 or not. If that is 0, then we need to push it into queue and mark it as visited. Okay, so like what we need to do, we will mark, we will take, like in queue we will take 0 comma 0. Yes, it is 0, so we will push it. 0 comma 1, yes, it's 0, we will push it. Checking 0 comma 2, yes it is, so we will push it. Now what we will do, 1 comma 0, yes, we will push it. Coming for 1 comma 1, that is 1, so we don't need to push it. Coming to 1 comma 2, yes it is, so what we will do, we will push it. Okay, now in matrix all the zeros are inside this queue. So let's initialize. We have initialized all this. Okay, now coming to the distance, we need to create a distance matrix. So let's create a distance matrix initially and mark the remaining one with -1. So let me create another matrix like this: 0 0 0 0, -1 will be initial distance, 0 1 1 1. Now what, in, after pushing this inside a queue, we need to mark the distance for this particular node as 0. That means we push 0 comma 0 in the queue. That means the distance for this particular 0 comma 0 will be 0. So this is the important point that you should keep in mind. Okay, and the remaining one will be unvisited. Like, so coming to main core idea, that means this is visited this time, this is visited, this is visited, this is visited, this is unvisited. Okay, okay, so let me start. First we'll start from 0 comma 0. 0 comma 0 is already visited, it is inside queue, so we don't need to do anything for this. 1 comma 0, like if it is already visited, then we need to check its adjacent node, that is 1 comma 0 and 0 comma 1, that is already inside a queue, so we don't need to check it. Okay, now that's done. Okay, coming to 0 comma 1, yeah, it's inside a queue, as you can see. 0 comma 1, it's inside a queue. Now we need to check for its adjacent node. Its adjacent node is 1 comma 1 and 0 comma 2. 0 comma 2 is already inside a queue, but 1 comma 1 is unvisited. So what we need to do, we will push it inside a queue. We need to pop it now, and we will push it inside a queue, and the distance for this will become 0 1. Okay, what we need to do, we need to simply add 1 inside a parent distance. That means its distance is, the parent node for 1 comma 1 will be this 0 comma 1, and its distance was 0. Then what we need to do, we need to add 1 inside the distance of this parent node. Okay, so what will be the distance for this now? For 1 comma 1, the distance will be, for 1 comma 1, the distance will be now 1. Let me mark all the things inside this distance array, so that, okay, the distance is 1 now. So let me erase all this thing. Okay, coming to 0 comma 2, this is already visited, as you can see. 0 comma 2, let me pop it out. Okay, 1 comma 0, it's already in queue. 1 comma 1, yeah, it's already in queue. 1 comma 2, yeah, it's already in queue. But what we left behind, like if we are here, that means we are at 1 comma 0, then we need to check for its adjacent node na. Like we need to check for 2 comma 0 and 1 comma 1. 1 comma 1 is already inside a queue, so we need to check for, we need to call BFS for this 2 comma 0. So what we need to do, like we need to push, we need to, firstly we need to remove this 1 comma 1 and push 2 comma 0 inside this 2 comma 0 inside this queue. Okay, that's wait, 2 comma 0 inside this queue, and the distance for this will be, distance for 2 comma 0 will be 1 because the parent is 1 comma 0 which distance was 1, so we need to add 1 inside the parent distance of that particular node. Okay, now as we saw, like for 1 comma 1, for 1 comma 0, 2 comma 0 is now already in queue, 1 comma 0 was in queue, 1 comma 1 was in queue. Okay, oh sorry, I removed 1 comma 0. Sorry, 1 comma 1 this time. Okay, that will be fine. So now coming to this 1 comma 1, yeah, 1 comma 1 is already inside a queue. So what we will do, we will remove this and check its adjacent node. Its adjacent node is 1 comma 2. 1 comma 2 is already inside a queue, and 2 comma 1, 2 comma 1 is not inside a queue. So what we need to do, we will, like, we will remove 1 comma 1. So let me remove 1 comma 1, and what we will add, we will add 2 comma 1. Okay, now the distance for 2 comma 1 will be, what will be the distance for 1 comma 1? That was 1. So what we need to do, we need to add 1 inside a parent distance. So the distance for 2 comma 1 will become, the distance for 2 comma 1 will become 2 this time. Okay, that's time. Yeah, we have already checked 0 comma 2, so we don't need to keep it inside a queue. We can remove. Okay, so that's done. Now coming to this 1 comma 2, yeah, 1 comma 2 inside a queue. So what we need to do, we need to remove it from queue and check its adjacent node. Its adjacent node is 2 comma 2, 1 comma 1, and 0 comma 2. 0 comma 2 was already in queue, 1 comma 1 was already in queue, but 2 comma 2 is not. So what we need to do, we need to remove it. Like, we need to remove 1 comma 2 and add 2 comma 2 inside a queue, and for this 2 comma 2 the distance will be, for 2 comma 2 the distance will be 1 because its parent's distance was 0. That means the distance of 1 comma 2 was 0, so we need to add 1 inside that parent distance. Okay, okay, so coming to this 2 comma 1, 2 comma 1 is already in queue. So what we need to do, we need to remove it from queue, and its adjacent node, like its adjacent node is this 1 comma 0 and 2 comma 1, that is already in queue. So what we will do, we will remove it. Okay, now coming to 2 comma 1, 2 comma 1 is already in queue and its adjacent node is 1 comma 1 was already in queue and 2 comma 2 is already in queue. So what we need to do, we need to remove it. Okay, coming to 2 comma 2, its adjacent node is 2 comma 1 was already in queue, 1 comma 2 was already in queue. So what we need to do, we need to remove it. Okay, now the updated distance metric will be, for 1 comma 1 the distance is 1. Okay, for 2 comma 0 the distance is 1. For 2 comma 1 the distance is 1. For 2 comma 1 the distance will be 2. Okay, for 2 comma 2 the distance will be 1. So this is the updated distance metric. So let me explain it one more time so that you can get it easily. Okay, what we need to do, firstly we need to check for all 0. We will store all the 0 inside this queue, and we will check its adjacent node. If its adjacent node is unvisited, then what we will do, we will, and also we need to check if its adjacent node should be 1, because we already pushed all the 0 inside the queue. So what we need to do, we need to check its adjacent node, and its adjacent node should be 1. If its adjacent node is 1 and it's not visited, so what we will do, we will do simply we will add 1 in the distance of that particular node. That means if we are checking for this 0, wait, yeah, if we are checking for this 0 will be already inside a queue, because this is 0. Okay, so what we will do, its distance will be 0. Its adjacent node is 1 comma 1. So what we will do, we will add 1 inside the distance of this 0 comma 1. 0 comma 1 is a parent node for 1 comma 1. Okay, so what we will do, we need to simply observe the thing that we need to add 1 inside a parent node if that particular node is 1. That's the simple formula for this question. I hope you got the dry run. So let me go in my Visual Studio Code and write. I will write the code. Okay, so I am inside this. Okay, here we have a grid. So let me wait. What we need to do, we will take a queue, int comma int. Okay, also we will take a distance matrix, and we will initialize it with -1. Okay, initially it will be -1. Okay, now we will check, we'll iterate over this grid, and we will check for int I is equal to 0 till n I plus plus, for int j is equal to 0 till m minus 1 j plus plus. Okay, what we will need to check, we need to check if grid of ij equal to 0, then what we need to do, we need to push it inside a queue, q dot push I comma j, and also mark its distance as 0. Okay, now what we need to do, we will check in all the four direction of this particular node. So we will take a direction array in dx of 4. Let me, okay, or as int dy will be 4. Okay, now we need to check whether queue is empty or not. Not queue dot empty. Then what we need to do, we need to find the front element, like auto it is equal to q dot front. Okay, we will pop it, and we will find the new node, like int x will be it dot first, and y will be it dot second. Now we need to check in all the four direction. Let me wait. For int d is equal to 0, d is less than 4, d plus plus. Okay, we will find the new direction, like int nx will be x plus dx of d, and y will be y plus dy of d. We have some boundary condition for this. Nx should be greater than equal to 0, and nx should be less than n, and also ny should be greater than 0 and ny should be less than n, and also distance of nx and ny equal to -1. And also what we can do here, instead of checking for distance, we can also check for that particular grid of nx and ny should be 1. Okay, so what we need to do, we need to calculate the distance of nx. Ny will be the distance, we need to add 1 inside the distance of parent node, that is distance of x and y plus 1, and also we need to push it inside a queue. Q dot push nx and ny, and that's done. What we need to do this time, we will print it. So I hope this work fine. Let me check it once. Let me save it first. cd.yt.cpp. Okay. Oh, sorry. That should be g plus plus yt. Okay. Give 3 cross 3 as input, and our matrix was wait, what was our matrix? Let me check it once. Okay, our matrix was 0 0 0, yes, 0 1 0, yes, 1 1 1. Okay, we got the correct solution. That means our answer is correct. So this code is fully correct. That means, so what was the core idea? That instead of running BFS from everyone, we optimize it using multi-source BFS from all zeros simultaneously. Okay, that means we use reverse engineering. So that's done for today. If you found this video, this explanation helpful, don't forget to like the video, subscribe for more DSA content, and I will see you next one. Until then, code chill, repeat.